Protons. How do they even work? We conjecture ahead.
Although this is going to be weird, and it's going to be about a different.
Title of the conference was something like Ground Truth or Turtles All the Way Down. And so it seems as though there's one Ruliad. I don't think it rules them all. And it might be just hyper-rulial turtles all the way down.
Yes, it's on the back of an infinite number of hyper-rulial turtles.
Various people are commenting on the outrage of hacking the universe on a MacBook Air.
Hey guys, what's going on? Memes here. So I'm not saying that I intentionally waited till 42 minutes past the hour, but it's a pretty cool number. I'm just saying. But hey, Whitechapel, thank you for joining, my friend. All right, so what the heck am I even talking about? Where does the massive proton come from? To be fair, this is an article from Forbes. The link's in the doobly-doo. I did it mostly for the picture. We want to give credit where credit's due. I'm just saying. But it's over 6 years old, but gives us the standard thing about it. It's like, all right, we got 2 up quarks and we got a down quark. That's our general understanding. There's some gluons and they're binding everything together. And that's how we got a proton. Isn't that a pretty representation? It's all these swirling things about it and everything. Kind of reminds me of a neutron star. Again, full disclosure, I'm a dude on the internet. I've had the privilege of talking with a lot of really smart people, including some people that may actually watch this video. Whitechapel's a pretty smart dude as well. I'm just, to be fair, it's a MacBook Pro. The turtle is a consistent meme that I learned the deep lore from Professor Wolfram. But I digress. Okay. So, what's going on? According to our best estimates, according to physics.nist.gov, mass of a proton, numerical value is to our measurements is 1.6762192369 times 10 to the negative 27 kilograms. That's really freaking small. And again, the Planck mass, it's 10 to the negative 8. That's a heck of a lot larger, like 19 orders of magnitude. All right, so you got the uncertainty there. Basically, we got about 51 for the last 2 digits there. So it could be up or down there. Okay. We go to our friend Wolfram Alpha. What the heck is this monstrosity here? So that monstrosity is actually of this extremely beautiful beam footage right here. What am I talking about? Okay. Yes, I'm using my thumbnail from the own. It's got the stuff and things that I want here. Okay. Got our code data. It's a little stretched to make it fit. And we got this equation here. Because according to Thad's work, the proton essentially it's the splitting map, the geometric tessellations of mass. That's to the best of my knowledge. Essentially, the proton is basically kind of reality itself, like splitting itself apart. I'm like, isn't positive supposed to be in? It's Ben, you took a guess. You took a guess. I'm not saying that might map on a lot better. I'm just saying maybe we should actually switch to the actual charge that we know it actually is. Just saying. But okay, what do we have here? The splitting map. This is to generate the mass of a proton. Since we generated the mass of the electron in the last video, the mass of the electron, and we have that divided by the mass of a proton. Oh, this is J2. This is J1. This is from the hyperbolic vortex equation. The link's in the TOE contest thing, so you can generate it yourself. Again, brackets. We square it. And we set it equal to this geometric articulation. This? A 2/3? If only there was something with the proton that could let us know if 2 out of 3 had something important going on. And like many things, we square it. And we multiply that. This is part of the primary action here. This is for the universal binomial prescription. This is the primary action, and this is the secondary action. And so Thad's been able to geometrically represent the 44 constants of nature. I think it's pretty freaking neat. Now, I can do stick figures. That's why probably stickdeath.com, it really played to me. It also played Super Beast, so that's one of my favorite songs. He was also different. He had claws and long hair. Leave me alone. So what's the second part of this primary action? Oh, this is the alpha Feigenbaum constant. One of the primary factors involved with bifurcations. Minus 1 squared. That makes up the primary action. The secondary action is going to be 1 plus or minus. In this case, it's minus 1/3. If only there was something involving 1 out of 3. We may not be able to see here because I totally have it covered by the data. This is the problem with using your own screenshot. That might have something to do with what else is going on there. And that 1/3 is multiplied by E, Euler's number, raised to the third, times the Euler-Maccheroni constant. This is times by our splitting map that we use. And Planck mass times Planck length, all divided by the Planck charge squared, equals 10 to the negative 7. So basically, you get 7 decimal points. You're moving over. So again, our realm of persistence appears to have a hinge somewhere, usually around 7 decimal places. If you look at the numbers long enough, you either go crazy or maybe you start to figure things out. And occasionally a hint there or there by email can help. I'm just saying. Okay. Thank you. Close out that preview there. But so how the heck do we get that? All right. We go back to our friend Wolfram Alpha. So this is basically just what we saw. It's in there in the numbers. You can click the link in the doobly-doo if you want to play around with it. Okay. This is the mass of the electron we got from that last video over there. So if we want to solve for the mass of the proton, all you do is just put x, just a variable. It's the thing we don't know. It's what we're trying to solve for. That's algebra and stuff. It's amazing when you actually are interested, you start to learn how like calculus and stuff works. Gaming is also very often math, I'm just saying. But yeah, and then we had, what was it, Ja2 divided by Ja1. Again, hyperbolic vortex, first and second answers there, square it. We said equal to 2/3 squared times the alpha Feigenbaum constant minus 1 squared. What's the alpha Feigenbaum constant? Or the Feigenbaum constants? Oh, it looks like bifurcation diagram. Oh, very neat. Where was it? Feigenbaum originally related the first constants of periodic doubling bifurcations in the logistics map, but also showed it to hold for all one-dimensional maps with a single quadratic maximum. Oh, as a consequence of this generality, every chaotic system that corresponds to this description will bifurcate at the same rate. Feigenbaum made this discovery in 1975 and officially published in 1978. Okay, that's one of them, and the other one is the one with the 2. There we go, the second constant. The alpha constant is the ratio between the width of a line and the width of one of the two sublines, except the closest to the fold. A fold, they say. Again, this is Wikipedia. Wikipedia. Again, the links to the doobly to investigate further. I think a lot of the stuff that is decent. Again, we're still working on it. A negative side applied to alpha when the ratio between the lower subline and the width of the line is, or the tine is measured. Oh, a teen. Excuse me. Teens are oh, okay. Oh, it's kind of like, oh, there is no true straight lines or something. But these numbers apply to a large class of dynamical systems. Oh, and driven population growth. Huh. Again, very neat. We got E here. E is a number known as Euler's number, is a mathematical constant approximately equal to 2.71. Again, get close to the CMB and Kelvin, just saying. But is the base of the natural logarithms, is the limit of 1 plus 1 over n raised to the n as n approaches infinity, an expression that arises from the study of compound interest. Oh, also nifty. And where's the... No, where's the macaroni constant? Give me the macaroni constant. I like saying it that way. Oh, let's go to Math World. Find the limit of the sequence. Oh, okay, where h is the harmonic number. Harmonics. I totally like music. Okay. So we put all those crazy things into the equation. This, again, primary action, secondary action. Now again, if only... We'll get to that in a second. I'm throwing the kayfabe off. But okay, so it comes out to this. That's cool. That's not the proton mass. Oh, look. We solved for it. We said equal to 1. That looks like the mass of the proton. 1.672 6219237 times 10 to the negative 27. Go to code data. Okay. 1.672 with there. Oh, I think we got more digits. 923, take off the last 2. 9237. Oh, look, that's a 6. My friends, that looks like a geometric derivation of the mass of the proton. I'm just saying, I think this is pretty freaking neat. But, yeah. So we got the links in the doobly-doo. Feel free to play around. Again, most of the stuff's been out there for a little while. Again, I think 2023 is the year to see. But thank you all for watching. Peace out, everybody. Be safe, and totally some truth out there. I think we're going to figure a lot of stuff out this year. I got hope. Be safe, everyone.
Have you guys checked out the Memes of Destruction's channel? He's an interesting dude. I like him.